So this video is basically, what I want to do in this video is start to talk in very practical terms about z-values and how to use a z-distribution table, standard normal table. There is a tremendous amount of resources that exist all over the place, online, YouTube, all kinds of different locations that will talk about these same kinds of concepts. Now, Dr. Holmes, Dr. Alexander Holmes, the individual that worked on our textbook, he's got some great videos, all right, and he does a really nice job with those. But what I don't want to do is replicate those. And so, for example, this video, what I want to do is talk in very practical terms about how we would go in and calculate a z-value and then use that z-value to find a probability in a normal probability distribution. Now, if we think about a z-value, all right, our z calculation is x minus the mean over the standard deviation. It's a massively simple formula, all right? We've already been exposed to this formula because when we started looking early on at Chebyshev and the empirical rule, we were basically doing exactly this. We were going in and we were saying, okay, we've got a normal, some type of a bell-shaped distribution. In the case of the empirical rule, we were specifying that it had to be bell-shaped and symmetrical. For Chebyshev, just as a way to deal with the problem, I've always kind of advised students to draw some kind of a picture that looks a little bit like this. But basically what we were figuring out is literally from this mean to some value of x, right, how many standard deviations fit in there. And that's literally what this formula is doing for us, all right? What we're going to do is just take this one step further, and now we're going to say we can use some tables, right? We can use a normal distribution table, and what we can do is then use that table to go in and say we can find different areas, all right, within this normal distribution based on this z-value, basically the number of standard deviations away from the mean that I am, okay? Now, these z-value calculations are very straightforward. We'll get into that in just a minute, but I want to cover maybe just the practical part of using these tables for a moment. You'll find a whole bunch of different types of tables that are available out online. Even within BA 254, we could use different tables. I'll try to be very consistent. The table that I've deployed in this section, all right, in this section basically just has, it's got along the top here, it's got a little kind of picture that looks something like this. All right, it says Z, and we got a little arrow here. All right, and then it has a series of different columns and rows, and we've got Z over here, and then we've got this function of Z. And basically what we're saying is this is going to be whatever area is on the normal distribution that I'm looking for that lines up to a specific z-value. So if we calculate a z-value and we find it to be 1.00, we can look at our table and see that the area underneath the normal curve at a z-value of 1 is 0.3413. Imagine we said we want a z-value of 1.50. If we go to look for that, 1.50, we end up at 4332. 4332. A value of 2.0 should get us to right around, let's see, 4772, somewhere in there. If we went for something, again, like 2.361, right? The table that we're currently using doesn't go out to the thousandths, but it's okay. In this case, I would just line up and say, let's just use the value 2.36. 2.36 gets us 2.4909, right? And so when we look at these values, one thing I will say is in terms of rounding, I get this question all the time. We will have a nice discussion about rounding as we go forward. I will always joke, it kind of depends upon, are you trying to do a marketing study or launch a missile? All right. For now, just use one of the corresponding values. Again, rounding either up or down. I've heard statisticians say, well, it's always more conservative to always round down. Well, it depends upon which part of the probability distribution we're looking at. So for now, when you round, because bear in mind, we're talking about a continuous variable here, right? We're talking all about continuous numbers. And so there's no limit in terms of the accuracy on this number. All right, so for now, just round up or down. When we get to a value, I don't know, 3.00, that's going to come out to be, on our z distribution table, 4987. Okay, so we're basically, in our table, we can go direct and find each one of these numbers. Sometimes you'll see a table that has the whole number and the tenths and then the thousandths running across kind of on the right-hand side. You're going to find different tables, but the one that we're going to use is just going to be a direct kind of correlation, direct link between these two numbers, all right? Now the takeaways from this. As this z-value goes up, right, what's happening to this number? Of course, it's also going up. But what we're going to do is we're going to then start to approach, as this number goes out to infinity, we're going to start to approach 0.500, right, or half. Because remember, in our Gaussian distribution, the mean separates the two sides, right? Mathematically, it's in the middle. This total area, the total area on this entire distribution is 1. So we're always going to find then that on one side of the mean exists 50% of the probability in the normal distribution. On the other side of the mean exists 50% of the probability. So we're going to get familiar with these tables. They're a great direct way to go about calculating these different probabilities. The calculation of these z-values are just massively straightforward. In the next video, to keep the size of this one down a little bit, we're going to talk about golf scores. So I'm going to read you off the problem that we're going to start working on in the next video. And it says the golf scores for a school team were normally distributed with a mean of 68 and a standard deviation of 3. So it says basically what is given to us or will be given to us in the next video. It says that the mean is equal to 68 and the standard deviation is going to be equal to 3. And then I'm going to ask a series of different probability questions. The first one I intend on looking at would say, what's the probability of getting a value between 66 and 70? Well, to start to do that, what I would do is say, all right, I'm going to go in and find now a z-value, for example, for 66. My 66 goes in here, 66 minus my mean of 68 divided by my standard deviation of 3, of course. So then, if I start running the numbers, of course, I've got -2 divided by 3, which gets me to a z-value of 0.66, lots of sixes. We'll just go to 0.67. Okay, so if I just simply asked what is the standard value for a golfer that scores 66, it would be 0.67. If I said, what is my z-value for a golfer that scores, I believe I asked, it's 70. You can see where this is going already. So now we've got 70 minus 68 divided by 3. Now instead of a negative 2/3, we have a positive 2/3. So instead of up here was a negative, missed that one. Now I've got a positive 0.67. So we can start to calculate these z-values. I'm going to do that on the next video. But then the extension is we can take these z-values and apply them through this table, the z-distribution table, to start to find individual probabilities. All right? It looks massively complicated, but let's step back and look at a couple of things. One, again, this is all, our main calculation is happening with this z-distribution formula, which is just fundamentally simple. And then when we look at our table, it looks worse because I'm just rewriting what the table says, but all of the hard work is being done by somebody else. In the past, I've joked, somebody in their grandmother's basement, so to speak, back in the day, saw this relationship and started to put these tables together. All of the hard work, all of these different areas underneath these curves are being handled by this table. And so it cannot get too overwhelming. Just hang in there. And as we develop then over the next videos, and as you start to start working through these problems, I think you'll find them to be very, very straightforward.